or 2 feet. Okay? All right, let's go up and define volume. It's the number of cubic units. And in the video you just watched, that was centimeters cubed. So it's the number of cubic units. It could be something else. It could be meters or feet or whatever. But generally, especially in science, it's centimeters cubed. Contained in the interior of a solid. So it's the number of cubic units contained in the interior of a solid, just like we saw in the towers. This was the warm-up. Okay? All right, let's practice this. Now, find the volume of the box by determining how many unit cubes fit in the box, just like the tower. What I want you to look at here is I don't want you to just say 3 times 6 times 3. I want you to look at it like this. How many cubes are in the bottom layer of this?
18.
Yeah, 18 altogether. 3 times 6. There's 18 cubes in the bottom layer, and how many layers are there? 3. So 18 times 3 is where it comes from. Okay? That is how you would find the volume. 3 times 6 is 18, times the number of layers, which is 3. So there's a total of 54 units cubed. Now this is really the same as volume equaling the base times the height, isn't it? The base is 3 times 6, and the height is 3. Volume is way easier than surface area. I'm just saying. Okay? All right, turn it over. The formulas are actually the same. I want you to realize that, again, the H is the height of the prism. H is the height of the prism. And the base is the area of the base shape. Now, when it's a prism, it could be a rectangle, it could be a triangle, or something else like that. For a cylinder, it's also volume equals base times height. But in the cylinder, the base area is always going to be what formula? I heard it. Who said it? Aiden?
No, that was me. That was Justin.
Justin, what is it? Yeah, because the base shape in a cylinder is always a circle. So you might want to just run it right this. If I were you, I'd get out my green sheet and write this right underneath the cylinder volume formula. I'd write this, because that's never going to change. This one, it might be different shapes, but this one will always be the same. Pi r squared h. I'd write it right underneath my volume formula.
I wrote to the right.
Okay, for cylinder only.
Yeah.
Okay. Now, let's find the volume of the prism here. Now, it's a prism. First thing I'm going to do is write down the formula. Always. Write down the formula. Then you stop and say to yourself, what is the shape of the base of this prism? What is the shape? It is a triangle. These are the bases here. Even though it's not sitting on them, those are the bases. Therefore, the capital B stands for area of a triangle. What's the formula for area of a triangle? If you don't know, it's on your green sheet.
Yeah, it's pretty much like A equals 1/2.
That's how you find the area of a triangle. So write that down in place of the capital B. And then the H still stands for the height of the prism. Okay. This is telling me that I need to find the area of this triangle right here. I'm just going to write it a little bigger. So, I'm going to find the area of that triangle. 1/2. What's the base of this triangle equal to? 1. What's the height of that triangle? 1. I filled in that part. What does the outside H stand for? The height of the prism. So again, this thing is sitting like this. Oops. Sitting like this, right?
Yeah.
These are the bases. If I were to tip it up, how high would it be? 8. Okay? Now you just got to do the math. Half times 1 is half, times 1 again is half, times 8.
4.
So 4 meters, we're talking 3-dimensional here. We're talking everything that fills up the inside of this. 3-dimensional, so it would be meters what? Cubed. Area is 2-dimensional, squared. Okay, so we got to find the volume of the prism. So again, I'm going to write the formula down. The volume of the prism. And I'm going to stop and say, what is the shape of the base? It's a rectangle. I'm going to just use this as the base here, because in a rectangular prism, you can choose. So I find the volume, or the area of that base by base times height. And I still include the height of the prism in my formula. So what's going to be in my parentheses here? 4 times 8 times 7. The height of the prism. And then you just do the math. Okay? All right. This is saying, how do the radius of the paint can compare to the radius and height of the can of carved wax? So they want us to compare radius to height. Make a ratio. So paint, what's the radius of the paint can? 3, and the height? 4. How about the radius of the car wax? 4 to 3. Oh, what kind of numbers are those? Yeah, they're reciprocals, okay? They're reciprocals. They are reciprocals. Smiley face. Okay, so now it says, well, how many times greater is the volume of the can of car wax than the volume of the paint can? Okay, so I'm going to find car wax first. Again, it's a cylinder, so I'm going to write down this formula, but I'm going to substitute it as this because my base is a circle. Then I just got to plug in what I know. Volume equals 3.14. What's the radius of the car wax?
4.
And the height of the cylinder? 3. So I'll tell you what that is. It's about 150.8 inches cubed. About 150.8 inches cubed. So that's the car wax. Let's do the paint can. Volume equals base times height. Well, it's a cylinder, so I know the base is pi r squared. Just plug in what you know. The radius is 3 squared. The height is 4.
Oh God, we got it.
It's 113.1 inches cubed. Okay, but we're not done. Almost. What was the question they actually asked me? How many times greater is the volume of this than the... Okay, well, does anybody have any idea how I would do that?
Nope. Track. No.
What if I asked you this question? How many times greater is 6 than 2?
3.
How would you do that?
Because it's, I don't know. Just guess.
You divide. How many times greater is 6 than 2? Well, 6 divided by 2 is 3. It's 3 times greater. So I can divide these numbers. Okay? 150.8 divided by 113.1. But don't do it yet.
Why not?
Because I'm going to show you something cool.
It's going to be 7.
Are you ready?
No.
Okay, looking at my graphing calculator here. I'm going to put that fraction in there.
Do it.
I'm not going to push enter. I want to do this. I want to do the math and reduce the fraction. You ready?
Ready.
Oh,
Oh my god.
what is it?
It's
Oh, look, wait, it's the same number. Isn't it sweet? This is 4/3 times bigger than that. It's like magic.
It's not magic.
Magic would be like you stretch the fish tank.
Listen, you don't have to do a lot of this kind of stuff on the practice, but there's a lot of this stuff. Here's what it looks like. I didn't put it out yet. Here's your worksheet. You have to write down what and what and what. Formulas. Don't move yet. Don't move yet. Formulas work in units. Look at this one here. Hey, there's no numbers. All I want you to do is write down the formula and substitute in the letters. So you're not going to come up with a number answer. Okay? This one, be careful. Look what they're doing here. What are they doing? They're giving you different units, right? I want you to use inches. Okay? All right, let me put it out for you right now. Always write the formula down first.
Mary, get off my calculator. Okay. Thanks.
What's that, Bob?